Hello everyone, welcome to Memo Neet. So I hope all of you are doing good. So first of all, let's have an introduction. All right. So I am a Prajita and I am your chemistry SME at Memo Neet. So you are going to see me here for a while. So what we are planning here is that you people are going to appear for the Brahmastra test series. So you people have opted for Brahmastra test series, and let me tell you that's a very good decision you people have taken. So we are going to start with the part test, right? And you are soon going to appear for the first part test, that is your BPT1. All right. So you need to prepare for that as well. So we are here to help you out with the preparation of that test. So from the chemistry portion, the first chapter that we have added in the Brahmastra first test is some basic concepts of chemistry. So let me tell you a little bit about the Brahmastra test series first. So here, the tests that we have made for you, they are in such a way so that you people can prepare simultaneously the topics of class 11th as well as the topics of class 12th, right? So most of you are in class 12th or you have completed your class 12th. So this time you will be studying about the class 12th topics, right? Then what about the class 11th topics? So don't worry about that. You will be doing your simultaneous preparation of the class 11th topics as well along with our Brahmastra test series. So that is why the very first chapter that we have added is the first chapter of class 11th, that is some basic concepts of chemistry. So let me tell you about this chapter first of all. So basically this chapter is all about the basic concepts of chemistry, right? So it will help you out to understand whatever basic concepts are there, and it will be helpful in future also when you will be studying different chapters. But apart from that, questions have been asked from this chapter also. That is, in your Neet examination, you are going to get a lot of questions from this first chapter as well. That makes it a very important chapter. All right, class. So keep your pen and paper ready so that we are going to start with the important concepts of this chapter. So basically the concepts that we are going to study in this chapter are the ones which have been asked in your Neet examinations like many times, okay, which are the most important topics, because basically we are preparing for our Neet exam. So we must be aware of the syllabus, aware of the type of topics and questions that are asked there. So let me tell you, the very first topic that we will be covering is your significant figures. So what I have observed is that there is at least one question asked from this topic, significant figures. All right. So we will be learning about that. Then today we will be learning about the laws of chemical combination, which is a very basic part of your chemistry. Because once you know about the laws of chemical combination, you might have studied it in your lower classes also, but we'll be talking about them in detail and we'll be learning some new laws as well. So these are very important topics from Neet point of view and for understanding the basic concepts as well. All right. So that is why I am starting with significant figures and laws of chemical combination. Other basic topics that you have in this chapter about matter, elements, compounds, mixtures, that we have all studied, right? So we will be starting by talking about the measurement, uncertainty in measurement, in which you have this topic of significant figures. So then we will be continuing with that, and then we will be talking about laws of chemical combination. Apart from that, if I tell you about this topic chapter, the most important concept of this chapter is the mole concept. So mole concept we'll be learning in this chapter. Okay, so be ready for it. So that we'll be learning in the next lecture, but this is a very important topic, let me tell you. Then we will be learning about the stoichiometry and calculations, all right. And then we'll be talking about how to calculate the empirical formula, the molecular formula, relation between them. Okay, so while we are learning mole concept, we'll be talking about atomic mass, molecular mass. So these are very basic things, no? That's why we are saying this chapter is known as some basic concepts of chemistry. So we at Memoneet here are here to help you out. Okay, if you have any doubts in this particular lecture that we are going to start, please feel free to post your doubts in the comments. Okay, whatever questions we are going to discuss, try to solve them on their own, on your own, right? So we will be together in this journey, and I am sure we will be achieving success very soon. So let's first start with our first concept of significant figures. Okay, so in chemistry, students, you all know that there is like measurements, a lot of measurements are being taken, no? When we are talking about the experimental stuff, I'm talking about practical chemistry. So in that way, we are talking about measurements. We have to measure the mass of the reactants. Okay, we need to measure the volumes, we need to know about the densities, we need to know about the temperature. All right, we need to know about many things about a particular substance. So these are all the measurements that are done in your chemistry. Like obviously in practical chemistry, when we are doing the experiments in lab, so all these things are measured. So whenever we are talking about the measurements, there exists some uncertainty in the measurements. So those uncertainty we are going to talk about. Okay, so to understand what is this uncertainty, let's take an example. All right. Now let's say I am measuring, the mass of any substance using the platform balance. Okay, these are different types of instruments that we have in our labs. Okay, these uncertainty actually creep in because of the limitations in your measurements only, right? Or your measurement instruments as well. So the mass of that substance using the platform balance is found to be 9.4 grams. But when I find it using an analytical balance, so that will give you a more clear value. Okay, a more precise value to be sure. So here I can say it's coming out to be 9.4213 grams. Okay, now what you can understand from here, that the mass of the substance that we are getting here is more in the case of analytical balance than the platform balance. So what I can say is, students, ki this 9 is fixed. I know that the mass of the substance is 9 grams. This I know with certainty. But after that, this 4, this is uncertain. Okay, this 4 is uncertain because I don't know that how much it is after decimal, like it is 9.42, 9.41 or something like that. So this is the uncertainty I am talking about. Okay, so I can say this digit 4 is uncertain. So that takes us to significant figures. This uncertainty is actually shown by the significant figures whenever we are doing the calculations. So what are significant figures, students? These are the number of certain digits, like the significant digits in a number, including the last digit whose value is uncertain. Okay, so whenever we are writing that last digit, that value would be uncertain. Like if I am saying 9.4 grams, so this is a significant figure. Here the value 9 is certain, but this 4 is actually an uncertain value. Okay, so this is called so here now I need to count how many significant figures are there. Okay, let's say I am writing any measurement, like I have measured any volume 11.2 ml. So this 11.2 ml means that this 11 would be a fixed value. It is known with certainty, whereas this 2 is an uncertain value with an uncertainty of plus minus 0.1. Okay, like plus, not more than that. Okay, but around plus minus 1, like it can be 11.1 or around 11.3. So in this range only this value, this uncertainty would lie. So now there are certain rules. Okay, this is something very important. Keep a note of it. Now, whenever you are making notes, I am sure you people are making notes. Of course, you will get it from us as well. But keep a notebook with you where you are going to make your notes. So whenever you are going to make your notes, here, make sure you are writing these rules. These rules are there for counting the number of significant figures. Okay, ki how we are going to count that how many significant figures are there in a particular given value. All right. So the first rule is all non-zero digits are significant. For example, in 285, I have three significant figures. In 0.25, there are two. Okay, like 285, all these are non-zero. There are three significant figures. 0.25 may non-zero. Check how many? Two are there. If I am writing 0.03, okay, that I will do later. But let's say I am saying it's 5004. Okay. So now there are four significant figures. Now you will say ki ma'am, yahan par to we have two zeros also. But if these zeros are there between two non-zero digits, na, then it becomes significant. Alright. So it's 5004. So yahan par we have four significant figures. Similarly, 2.05, I have three significant figures. Keep the examples noted as well. Because when we study with the help of examples, things become easy to understand. Alright. So here please note class कि I have three significant figures in this case. Okay. Alright. So all non-zeros are digits are significant, plus keep noted कि the zeros that are there between two non-zero digits, that will also be significant. Now, okay, that was the third point that I've already explained. Ki zeros between two non-zero digits are significant. Like if I'm talking about 2.005, so tell me how many significant figures are there? 4. Okay. Now, second point was that zeros preceding to first non-zero digit are not significant. Ki if you have some non-zero digit, usse pehle wale zeros, right? The zeros preceding to it would be not significant. They just like indicate the position of decimal point. Let me show you like 0 0.03, 0 0.0052. These are the numbers that I have. So the zeros preceding to 3, they are not significant. So how many significant figures would be there? Only one. Similarly in 0 0.0052, how many I have? 2. Okay, because these zeros are not significant. That you must note. Okay class, I hope it is understood to everybody. Now let's move on to the next one. Zeros at the end. This is a very important point. Zeros at the end or right of a number are significant provided they are on the right side of a decimal point. Let's say 0.200 is a number. How many significant figures it has? 1, 2, 3. 3. Because these zeros that are after the decimal point, now on the right hand side of the decimal point, they will be significant. Okay. But if you have no decimal, let's say I am having 100 number. This is a number 100. Now tell me how many significant figures are there? Yes. Just think about it. There is no decimal here. Okay. It can have one significant figure also, 3 also, 4 also. Now you will say, ma'am, how is it possible? Because when we are having such numbers now, what do we do is, we are going to write these numbers in the form of scientific notation. Okay, I hope we all know what are scientific notations, where the decimal is placed after the first digit only, and then we use 10 to the power something to express big numbers. All right, because in chemistry we deal with large numbers, right? So let's say I can write 100 as 1 into 10 to the power 2. Okay, now this 1 is significant, so we are not counting these things, no class, 10 to the power 2, that we are not going to have in the significant figures. So this number has one significant figure. Okay, now if I write it as 1.0 into 10 to the power 2, that it means 100 only, na? These are just different ways in which I am representing. So how many significant figures? Tell me. So basically here I am having a 0 after decimal point, and just now we have seen ki zeros after the decimal are significant, so there will be two significant figures. See, that's why I told you there can be any number. So if I can write 1.00 into 10 to the power 2, so it is going to have three significant figures because there are two zeros that I have put, no? So that is the thing, class. This is how we are going to count the number of significant figures for such numbers, because we are going to write them in scientific notation. Okay. Now when we count any number of objects like 2 balls, 20 eggs, they can have infinite significant figures, because I know I've told you I can write it at any, I can put any zeros after the like, see, I can put n number of zeros, infinite number of zeros in front of 2, like 2.0000000. So that is why I am saying these are exact numbers, and I can put infinite number of zeros, so can be infinite significant figures in this case. Okay. Now what we need to understand is, I think we have all understood that how we are going to find out the number of significant figures. But when we are doing some calculations, okay, this is something important from chemistry point of view. When we are doing some calculations, like I am adding these numbers, let's say 4.523 plus I am adding 2.3, then 6.24. So please add it, class. Please add it and you will get the answer 13.063. Now I am not going to write this answer as 13.063. I am going to write it as 13.1. Now you will say, ma'am, how this is happening? So the rule says that whenever you are doing any operations like addition, subtraction, multiplication, division, in the answer you have to put only those significant figures that are there in the least number of significant figures, in the value having least significant figure, that we have to put. Okay, so let me show you how. So whenever you are doing addition or subtraction, the number of digits to the right side of decimal cannot be more than what is there in the number having least number of digits. So यहाँ पर we were having 3 digits after the decimal, 1 and 2. So 1 is the least. So whenever we have to report the answer, this is called reporting of the answer. So whenever I have to report this answer, although the answer is this one, but I have to report just 1 digit after the decimal. Now how I am going to convert this 13.063 into 1 digit after the decimal? I have to round it off, right? So I hope you know the rules of rounding off. I'll tell you once again. So whenever the digit is more than 5, so we write the next digit. So 13.0 will convert to 13.1 because here the digit is 6, For if it's less than 5, so we write the previous number, and if it is equal to 5, let's say if I'm having 13.15, okay, and 13.25. So this is exactly 5. Now what you will do, it's not greater or less than 5. So if it's an odd number, it goes plus 1, it will become 13.2. If it's an even number, like here if I have 2, so it remains same. It will remain 13.2 only. This is how the rule goes. Okay. And yeah, if it is less than 5, so it will remain 13.0 only. Alright. So this is how it happens. But if I talk about the multiplication and division thing, so the rule here is that let's say I'm multiplying these two numbers. So here I need to count the number of significant figures in the least number of significant figures. So I can see here there are 4 significant figures. Here I have 2. So these two, in the answer, I cannot report more than 2 significant figures. Understood now? One number is having 4 significant figures, other one is having 2. So in the answer, I cannot report more than 2 significant figures. So when we multiply, please do multiply it, class. I am having this answer, but I cannot put more than 2 significant figures. So it means I can just put the answer as 12. Okay. Because 12.11 will be rounded to 12 only. It's less than 5. Similarly, do one thing. I'm giving you this number 2.5 into 1.25. Just multiply it. And what will be the answer reported in this case, that you need to tell. Okay. So let's see. The answer is going to be 3.125. But the least number of significant figures is 2 here, 3 here. So I need to just report 2. So 3.125 will be rounded off to 3.1 only because the number 2 is less than 5. So this is going to be the answer. Okay. So I think this much part is clear about the significant figures. This much is required in your NEET examination. You must know how to count the number of significant figures. These operations, these are important that I've told you now whenever you have to report the answer. Now we will be discussing the laws of chemical combination in brief, okay? Because you must have an idea about what these laws are saying. So let us discuss these laws one by one, everyone. Okay. So what are the laws that we are going to discuss? So here you can see, students, these are the laws of chemical combination that we are going to discuss. Most of you, like some of these laws you have already studied in lower classes, but these are important. So let us recall them. Yes, questions can be asked from these laws as well, right? So the first one is law of conservation of mass. This is the very basic law that is applicable whenever chemical reactions happen, okay? So law of conservation of mass says that mass can neither be created nor be destroyed, right? This is the very basic thing that we have been studying since our 9th standard, right? That mass can neither be created nor be destroyed. So whenever a chemical reaction happens, okay, the mass can be converted from one form to another. It cannot be created or destroyed. Alright, so in that case, we say that whenever a reaction happens, the total mass of reactants, the reactants that are reacting with each other to form the product, so the total mass of reactant is going to be equal to the total mass of products. So this is the thing that we always have to keep in mind talking about the law of conservation of mass. Okay. So this is very basic law, but you know what happens in nuclear reactions class? कि nuclear reactions में it is found out कि the mass of product, this is an additional information, okay? So the mass of product is slightly less than the mass of reactants. Now how this is possible? Because according to Einstein's mass energy relationship, which says A is equal to mc square, you know, remember this? A is equal to mc square. So what happens is, according to this, we can explain that some of the mass has been converted to energy. Okay. It's not that the law of conservation of mass is violated. No, it's not being violated. There are some change that we can make to it. Mass has been converted to energy. Okay. So what I can say is that this law can be called as law of conservation of mass and energy. Mass and energy can be converted to each other, but they cannot be created or destroyed. Mass is not getting destroyed here, it is getting converted to energy. That's why we are saying that mass of product is slightly less than the mass of reactants in case of nuclear reactions I am talking. In our normal chemical reactions, the mass law of conservation of mass is applicable, okay? Now let's talk about the second law, that is the law of definite proportions. This also you have started in your lower classes. So whenever we are having any chemical compound now, you know that chemical compound is formed by the chemical combination of elements. So this law actually says that the chemical compound always contains exactly the same proportion of elements by weight. Now, I think it might look a little bit difficult to understand, but I'm here. See, whenever some elements are combining to form a compound, they will always combine in same proportion by weight. No matter whatever the source is, means it is irrespective of the source. Now, if I tell you that students take some water from your home, if I take some water from my home, if some person takes water from America, if you take it from any sea, any oceans, so you know the chemical formula of water is H2O now. And what is the atomic mass of hydrogen? It's 1U. And for oxygen is 16. So can you find out the ratio of masses of hydrogen and oxygen? So how many hydrogen atom I have in water? 2, right? 2 into 1. And for oxygen it's 16. So the ratio will come out to be 1 upon 8. It means that hydrogen and oxygen are combining in 1:8 by mass. Okay, we are talking about the ratio of masses. So 1:8 by mass to form water. and that is going to be same everywhere, okay, because it's a chemical compound. If you take water from any source, it's not going to change. That's what law of definite proportion is telling us. Let me give you one more example. If I talk about carbon dioxide, carbon's mass is 12 and oxygen's mass is 16. In the meantime, I'm writing the reactions. Calculate the ratio, okay, of carbon and oxygen in which they are combining. Do it. So I can say कि carbon dioxide I can prepare in many ways. By heating calcium carbonate, okay. By burning of coal, carbon dioxide can be produced. By the reaction of HCl on your marble, that is again calcium carbonate. These are some of the ways I have written कि CO2 can be produced. So have you found out the ratio, the mass ratio? So carbon is 12 and for oxygen there are 2 atoms, no? So I have to take mass of 2 atoms, 2 into 16. So 12 upon 32 it is, right? So 4 3s are 12, 4 8s are 32. So the ratio is coming out to be 3:8. Now what do you think? Carbon dioxide में the ratio is 3:8. Is it going to change for these different reactions? It's going to be different for different reactions. Because the source of production of carbon dioxide is different, no? But that's not going to be the case, class, because whatever the source of production is, we are getting CO2. In all of these CO2, the ratio of carbon and oxygen combining by mass is 3:8. Okay, so that is not going to change. So that's what law of definite proportions is. I hope everybody has understood that. Now let us see the third one, law of multiple proportion. It is also like similar to that. We will understand it again by example. So this law says actually when two elements, they combine to form more than one compound. Okay. So it's not necessary na ki when two elements are combining they will form only one compound. They more than one compound. Like hydrogen and oxygen, when they combine they form H2O, which is your water. They can form H2O2, which is hydrogen peroxide. Similarly, carbon oxygen forms carbon monoxide, carbon dioxide. So let's see what is the mass. Okay, whenever water is formed, in case of water, the mass of hydrogen is let's say 2 grams and mass of oxygen is 16. So it is forming 18 grams of water, right? Now in hydrogen peroxide, what is the mass of hydrogen? 2 grams, since there are 2 atoms, but the mass of oxygen is 2 into 16, 32. So this law says that when two elements combine to form more than one compound, mass of an element which combines with fixed mass of other element bear simple ratio to each other. Now what is that like what is that saying? I'll tell you. So mass of oxygen here is 16 and here it's 32. It's combining with fixed mass of hydrogen, no, which is 2 grams. In this case 2 grams hydrogen in this case. Now these two masses will bear a simple ratio with each other, that is 1:2. That's what we are talking about. Okay, that the mass of one element which is combining with a fixed mass of other bears a simple whole number ratio. That's the thing that we have. Okay, all right. So I think this one is clear to you. Next is Gay-Lussac law of combining volume. This is again an interesting law. Let's see what it is. So students, Gay-Lussac law, it actually says, it is talking about gases, okay. So whenever we talk about gases, they are combining with each other or they are produced in a chemical reaction. So this law says that whenever the combination of gases is happening or whenever the gases are produced in a chemical reaction, they do so in a simple ratio by volume. Okay, means that combination will be happening in a simple ratio by volume, provided all the gases are at same temperature and pressure. Because you know कि gases का जो behavior है, it changes with temperature and pressure. So if there is same condition of temperature and pressure, gases will combine in a simple whole number ratio. Now to understand this, let's take an example. Hydrogen gas combines with chlorine gas to form HCl gas. Okay. Now can you see the number of moles here? So here I am having one volume of hydrogen gas. It will combine with one volume of chlorine. But how many volumes of HCl I am getting? Just see the coefficient. I am getting two volumes, right? So the ratio is going to be 1:1:2, which is a simple whole number ratio. That's what this law says. I can take one more example here of hydrogen and oxygen. So hydrogen gas, it actually combines with oxygen to form water, but you need to write a balanced equation here, okay? So it means it would be 2H2 and here it's like 2H2O. Now can you see the ratio in this case? So here two volumes of hydrogen combine with one volume of oxygen to form two volumes of H2O. So the ratio is 2:1:2. Now how this is applicable? See, if I tell you I am having 100 milliliter or like that's what I can take volume 100 ml of hydrogen. So it will combine in 2:1:2 na. So it means it will combine with 50 ml of oxygen gas to form 100 ml of H2O gas, right? Water vapors. So see the ratio is going to be same. It's not going to change, provided all of them are at same temperature and pressure. That's something very important. Okay. Next one is Avogadro's law that we will be studying more when we'll be talking about mole concept. But actually Avogadro says he actually talked about the number of atoms and molecules present in any substance. So he said equal volumes of all gases. I'll write it for you. So Avogadro's law, it actually stated कि equal volume, if we are having equal volume of all gases, like any gas, and if they're present at same temperature and pressure, they will be having equal number of molecules. They'll all have equal number of molecules. If I say I have 1 liter hydrogen, if I have 1 liter oxygen, if I have 1 liter nitrogen, and if they are present at same temperature and pressure, the number of molecules present in them will be same. Now how many, that we will be talking when we will be learning the mole concept. Okay. So this was just an idea about Avogadro's law. So these laws were given like very earlier. So the first two were also given, law of conservation of mass and law of chemical like definite proportion. You might have also studied about Dalton's theory. I'll just give you a brief idea about it. Dalton's theory, we can say. He actually said that all the matter is made up of tiny particles, tiny indivisible particles, which he called as atoms. His postulates were later like not proven to be true, because again atoms were not like indivisible. We can divide it into electron, proton, neutron. No, then he actually said ki whenever you have atoms of one element, okay, atoms of one element, they all will be identical in all the properties, and atoms of different elements will be different in all the properties. That's what he said. Then he said again the law of definite proportion, he took it and he said ki the elements, they combine in fixed ratio to form compounds. But that is again not applicable when we are talking about isotopes, right? Then atoms are neither created nor destroyed. He said that whenever a chemical reaction happens, atoms can neither be created nor be destroyed. They can just be rearranged in a chemical reaction. So I told you this just to make you recall the concepts of Dalton's theory. But from this particular session, we have the topics, that is the topic of significant figures, that is important because numerical problem can be asked from this, and try to recall all the laws that we have given you, okay, because some practical problems could be asked from the law of chemical combination. Now I am going to give you a question to solve, okay. So what you need to do is, it's from significant figures, a very simple question. I just need to see if you people have understood it or not. So what you need to do is just put the answers in the comment box, alright. I will see it from here and then we will discuss the solution in the next section, okay. I hope it's acceptable. Just one simple question, hardly it is going to take 5 minutes of yours, okay. So that's what I am going to give you along with the option. Of course, it's going to be an MCQ problem. Let's see. So students, the question goes like this. The density of a solution is 2.15 gram per milliliter. Then the mass of 2.5 ml solution in correct significant figures is. Okay. So I'll tell you how to solve it. Just a little bit idea. The density is given 2.15 gram per milliliter and the volume is given, which is 2.5 ml. So for this solution you need to find out how much mass would be there, but the answer that you have to report, it has to be in correct significant figures, okay. Means it, I told you, you will be applying the formula of density, which is mass upon volume. So mass will be density into volume, right? So when you are multiplying these two values, when you are reporting the answer, it has to be the equal number of significant figures that are there in the least one, like the least number of significant figures. It cannot be more than that. So I want you people to give the correct answer to me in the comment box, okay, and we will be discussing it in the next section. So this was it for today, and I am telling you the next session is going to be very interesting and very important because we are going to talk about the mole concept, okay. And you are going to get a lot of questions in your Brahmastra test BPT1 from the mole concept as well. So don't miss that one also. And for today we are winding up now. So thank you so much students. Take care. Bye bye.